Evening, I'm Spot On Weather meteorologist Matthew Euler, and welcome to my latest training video. Basically, we're going to make weather simple in our training series, and that's what I aim to do every time we do these training videos. For this particular video, we're going to talk about fog. First, we're going to look into what is fog. Fog is simply a stable cloud with its base resting on the Earth's surface. It is composed of minute water droplets that are suspended in the atmosphere, and fog may be formed in one of two ways. Either air can be cooled to its dew point, reaching saturation, and in my last training video we talked about cloud formation processes, and we talked about the importance of saturation. When the temperature is cooled to the dew point, it results in saturation in the formation of clouds. But in this case, we have a cloud that actually is resting on the Earth's surface, and that is exactly what fog is. Additionally, fog may be formed when you take moisture, you add it through evaporation from surface sources such as lakes, rivers, and streams. And an example of that is in this excellent picture here. You'll notice that we have some kind of lake in the picture, and we have the fog right above the surface of this lake. And so we can have moisture added in this regard too to form fog. All right, so now let's delve into the various fog types. We're going to talk about 5 fog types in today's training video. We're going to look at radiation fog, advection fog, upslope fog, evaporation fog, and frontal fog. Let's start with radiation fog. Now, with radiation fog, nighttime or nocturnal cooling of the Earth's surface is going to cause the air at the lowest levels to be cooled at a fairly rapid rate. When saturation is reached, where that temperature cools to the dew point, fog is going to form, and it's primarily caused by radiational cooling. When we talk about radiation fog, think radiational cooling. That's that long wave cooling, the long wave radiation from the Earth and that cooling of the Earth's surface overnight. So this is just an example graphic here on the left, kind of just showing you that long wave radiation escaping from the Earth. And as this heat from the day escapes back out into the atmosphere, the air near the surface is cooled or chilled. And so you get the temperature to cool the dew point, saturation occurs, and you get fog closer to the surface here in this case, when we have that heat escaping out via this long wave Earth radiation overnight. Radiation fog, by the way, is going to form the best on clear nights when you have these shallow layers of moist air that are trapped near the surface. Again, as Earth's surface cools, the air cools directly above it. This generally tends to form an inversion. So whenever the Earth's surface cools at a more rapid rate, let's say right at the surface and above the surface, we actually have warmer temperatures. So let's say the temperature at the Earth's surface on a particular night is sitting at 53 degrees Fahrenheit. And then we go up to about 1,000 feet above the Earth's surface, and let's say the air temperature is actually 55 degrees Fahrenheit, warmer as you go up in the atmosphere from the ground. So radiation fog forms under these conditions when you have an inversion being temperatures warming with height. So you have a warmer air layer above a cooler layer at the surface, and that's when we talk about an inversion. And it is conducive to produce this radiation fog. Now, the stability of the atmosphere is increased in the low levels, and the air quickly cools to saturation. What is one of the more favorable situations for radiation fog to form is longer nights. So this would be during the winter time, right? We typically have longer hours of darkness. So when you have longer nights, that gives the cooler air to the surface more time to cool to the dew point, to saturation. So that's going to increase the potential for radiation fog formation, specifically during the winter months. Additionally, with radiation fog, it's going to be thickest. It's the thickest fog is going to occur with lighter winds to avoid stirring of the cold, moist air. With radiation fog, especially the thicker fog, you want nearly calm to very light winds. The winds cannot be that strong or the atmosphere will be mixed, and that will tend to dissipate the fog. And radiation fog, if you live near mountains, is quite common, in, particularly when you live near mountains, particularly if you live in a valley. Radiation fog is very common in valleys where you get this cold, dense air to drain down the mountain slopes overnight. And that colder air then settles into the valley, saturating the air mass and the valley air, resulting in valley fog. This is a nice picture here on the right, just showing a stratus layer here, very layer-like cloud structure, and you kind of see the fog going down into the valleys here, right? You can see this smooth sheet of cloud here. That's the fog going all the way into the valleys as the cold air drains down this higher elevation. So that's a really nice picture. All right, so let's move on to the next type of fog we'll talk about, and that is advection fog. When you see the word advection, we talked a little bit about that in my heat transfers video for training. Advection occurs when you're basically moving some meteorological property in the horizontal. So with advection fog, it occurs when you get this warm, moist air moving horizontally over a colder surface. It's advecting or moving into. So warm, moist air over a cooler surface. Now when that warm, moist air comes in contact with the cooler surface, it is going to be cool from below, and if the cooling continues to the saturation point, again, where that temperature and dew point are the same, we've got 100% relative humidity, the moist air is going to condense out and fog is going to form. I have a little story to share about advection fog. I remember traveling one time on a ship from basically the Hawaii area up into the Bering Sea. Now this period of time was in late July through September, and I can just recall the advection fog. I was up in the Bering Sea, and for days on end, we had advection fog. What's really causing it, specifically in the northern latitudes, like Alaska, in the summertime, is when you have warm southerly winds on the backside of those subtropical high pressure systems, warm southerly winds, warm and moist air moving over a cooler surface. So the further north you get in the North Pacific or the North Atlantic, you're going to have that warm, moist layer air cool the low levels via saturation, and you're going to get some thick fog, get some really thick sea fog in the summertime in the northern latitudes over the unfrozen waters. Additionally, advection fog is common along coastal areas, Seattle, Portland, Oregon, and San Francisco. You see a lot of fog there in the San Francisco Bay. It also, surprisingly, I've experienced this firsthand, the second bullet here. It occurs along the Gulf Coast during the winter months. And this is so true. I mean, I was living around Pensacola at one point, down the panhandle of Florida. I remember the winter nights down there, okay? They were chilly, but there'd be cases where you get really foggy nights down in the Florida panhandle over towards Mobile. And visibility goes down to like an eighth of a mile. It is so thick and dense, this advection fog. And what happens is you may have a day or two where you get cooler air that moves down into the Gulf of Mexico, get cooler air along the Gulf Coast over the land areas as high pressure. I'm going to draw this out for you, and it's probably best to explain it that way. Okay, so what happens is, just follow me here. All right, so initially, here's high pressure, okay? Initially, you get cooler air, northerly winds on the front side of these high pressure systems that go down to the Gulf of Mexico, down to the Gulf Coast. So this air near the surface is going to be cool and chilled. What happens though is as this high pressure moves off to the east, you then get a return flow from the south of the winds. And you still have the chilly air here at the surface. You still have that cool air. You still have this cool air at the surface. And you get this warm, moist air that's going to run basically southerly winds right from the Gulf of Mexico over this cooler ground, the cooler land, and it results in extensive, thick advection fog. This is some of the thickest fog I've seen, like I said. I mean, I've experienced night after night in the winter. I used to really follow the weather closely, keep weather journals down there when I lived on the Gulf Coast. And this is a very common occurrence down in that area in the winter months. Very common. So, yeah, if you're expecting to get a getaway vacation down the Gulf of Mexico, you go to the Florida Panhandle anyway, be ready for some thick fog overnight, thick convection fog. Next, we'll talk about upslope fog. Okay, with upslope fog, this is generally going to occur when moist air is pushed upward along the surface of an elevated plain, hill, or mountain, and it's quite common in the winter. Again, with those longer nights, the sun is what the fog does not want to have in place, because when the sun comes out, it basically raises the air temperature, and it basically causes the air temperature to go further away from the dew point, and it causes a drying out and a dissipation of fog. So again, the common theme here with a lot of these fogs is wintertime, long nighttime periods. Spring can also produce this upslope fog, and think about it, very common in winter spring along the windward side of the Rocky Mountains here. Okay, it also can be common on the east side of these Rocky Mountains. Whenever you get a cold high pressure system to the northeast and that clockwise flow northeast winds blow up against this normal leeward side of the mountain slope, you can get socked in with fog as well. I'm trying to think of an example here. Okay, I was on the road one time traveling through West Virginia, and that fog, it was a winter situation, it was late December. That fog was so thick around those elevated areas. I mean, you could barely see driving. The road was wet from rain. It was a very treacherous drive at nighttime, and going in between the passes of those mountains, the Appalachian Mountains. It wasn't fun. I couldn't wait to be done for the night, to be honest, and pull off the road. But anyway, yeah, this is upslope fog. Again, a wintertime in spring as well. Evaporation fog. This is a common form of this evaporation fog is called steam fog. I've seen this before over warm ocean currents. I've seen this. All right, it forms when you get colder air to move or evect over a warm body of water. So this water, the initial picture I showed you, the lake, with this steam fog or evaporation fog above it, this evaporation fog is going to be caused by a warmer body of water and colder air above it. And as that warmer water is evaporated into the atmosphere, it is cooled to saturation and forms this type of fog. It also occurs when it rains on hot summer days. I've seen this before. I've looked outside. So the sun is out during the summer. It's intensely heating your road pavement, right? Then you get some nice, thunder shower to come in there, and you see that residual water left over in puddles on that road. But then you'll start seeing a little bit of steam coming off those puddles, and that is because you have cooler air temporarily above that very hot surface, and evaporation is occurring over that puddle, and you're getting these little wisps of steam fog over the puddles on those hot streets on the hot summer days. It was really small scale. You really had to look close. I actually did a quick zoom in video on that process. It was really cool though. But just remember, with evaporation fog, I'm gonna spell it out right here for you to remember. It is like this: cold air. So cold air is going to be moving over warmer water. Okay, that's what forms this evaporation fog. So cold over warm situation. Colder atmosphere, warmer water surface. It could be a lake, it could be a river, it could be a swimming pool. I've seen above ground swimming pools in the Midwest. One of the first surges of really chilly air, and that pool is uncovered. The above ground pool in the backyard is uncovered, and I've seen that mist just kind of come up, the cooler air moving over that warmer water in the swimming pool, and creates this little mist here and stuff, right? So that's kind of another example of it. Here it is, evaporation fog again, just kind of honing in on the processes that are involved here. We have, let me go back to my pointer here. So we basically have this colder air again moving over a warmer body of water. Rising steam may become thick enough for fog. I've seen this over the Gulf Stream ocean current as well, with bitterly cold Arctic air masses coming off the east coast of the U.S. over the Gulf Stream, and I've seen this misty. It's just so eerie. It's like a smoke that comes in off the water. Frontal fog, another type of fog we can discuss. It's a common occurrence ahead of warm fronts. It really is. I have seen this one also in action. And so if you notice the diagram here, we have warm, moist air. Okay, I'm going to have to draw it out for you to really explain it. But you have warm, moist air because it's lighter in density. It's going to basically ride up and over this colder, drier air at the surface. Okay. Initially, what you get with this warmer air moving in over the cooler, drier air is you get this precip is going to evaporate because you have a dry layer. This evaporating warm rain droplets basically saturate the atmosphere, especially closest to the ground, near the Earth's surface, and you get this blanket of fog to form as that warm, moist air is riding up and over the cooler, drier air. And again, the main focus here is we're getting warm raindrops falling through that dry layer, and they're evaporating into a layer of colder air. And this process is going to allow the air to quickly reach that saturation point where your temperature is going to cool to the dew point and form a very thick fog. So I've seen this one in action as well. Now we talked about fog formation. You can add moisture to it. You can cool the temperature to its dew point. But let's finish this training on fog by talking about how do you get rid of fog dissipation. And there's been many cases at airports where, they're trying to resume their normal flight operations. Flights are delayed, and it's just a thick fog over these specific airports. And there's been a lot of different methods, man-made methods trying to be used, such as some sort of big mixing fan to kind of mix out the moist air to try to get rid of dissipate the fog. There's been cases where you have these really giant big burners that try to heat the air mass and get that temperature to not equal the dew point. Basically, the temperature would increase away from the dew point. So there's been other methods tried, like at airports, just to try to, especially foggier airports, to try to alleviate the travel impacts with all the delays. But really what it comes down to for fog dissipation, let's talk about this. We need an increase in temperature due to incoming solar radiation. That's the most effective method. So you may notice, initially even on a winter day, early in the morning, you look out your window, you see thick fog. It's still dark outside. As soon as the sun comes up, you may notice how this fog slowly dissipates because that incoming solar radiation from the sun is starting to heat the air mass, and that's causing that temperature to go up away from the dew point. And so as the air warms, that relative humidity then is going to decrease. Remember, warmer air can hold more moisture than cooler air. So you're warming the air with the sun and incoming solar radiation. The air particles then become drier. Fog may also dissipate if moisture is decreased. For example, if you get a change in wind direction or if the amount of atmospheric mixing is increased enough. So, you get enough wind in the atmosphere. It goes from calm to, the wind starts picking up. You can also result in more mixing of the air, and that can be enough to decrease the relative humidity through those stronger winds. That'll get rid of some fog. And then, by the way, fog normally dissipates from the outside edges inward. All right, that wraps up my training on fog. Fog is a very interesting topic in society, isn't it? What do we associate Halloween? Let's just use Halloween as a holiday, or any kind of scary movie you watch. You always see the mist or the fog. The fog is a mysterious type of weather element. I remember living out in Central California, and the place I lived in, it was so unique, the fog, that you would drive in one portion right there near the coast, and there would be no fog. And then you would slowly just see it come in, it would go down certain streets. It's almost like it was alive. But it was just the oddest thing before that fog kind of formed and moved in off the cooler waters off the Central Coast of California. It was really cool to observe the changes over such short distances with fog. So I hope you enjoyed the presentation. We covered fog. We covered what fog is. Remember, it's just simply a cloud on the Earth's surface. It's composed of minute water droplets. By the way, there are cases where you can get freezing fog. I forgot to mention that here. You may not necessarily have liquid water droplets. If you get temperatures, at freezing, around the freezing point, 32 degrees Fahrenheit or lower, you can actually get freezing fog. And that is very dangerous to drive in because, It's not really precipitating. The clouds aren't really coming, there's no form of precip hitting the ground. It's just this mist, but it's enough mist to really make things icy on the roads. So freezing fog does occur as well, in addition to regular fog with these minute water droplets. Bottom line is, for fog to form, you want air cooling down to its dew point, reaching the dew point. You also want to add moisture. You can add it through evaporation from water surface sources such as lakes, rivers, streams. We talked about the fog types here again. Radiation fog most common in the winter months. You want very light winds. You want clear nights to allow the most ideal radiation cooling to form radiation fog. And then, valleys. Valleys are very prone to radiation fog because colder, denser air drains down higher elevations, down the slopes of the mountain. There's advection fog, typically associated with the west coast of the United States. You can get upslope fog, evaporation fog, and so on. All right. That's all I got for now. I've got much more ahead for the training video series. We try to make weather simple so you can easily understand these processes that occur. I thank you for your subscription to the Spot on Weather YouTube channel. And until next time, God bless and take care, everybody.